So very good afternoon. My point of view is from a scientist perspective point of view. What you have seen for last three talks, definitely ARB is very, very strong. Now the questions which is being asked, is ARB is too strong? It is very stringent. And the stringent has come from the fundamental science logic. As has been told that 2047 and net zero, I will not go into detail. The point which is being made is that energy is very essential if you want to become a developed nation. Our current SDI index has to go from 0.6 to 0.8. And our per capita power consumption has to go by 5 times. So whether we produce nuclear energy or not, nations wants the energy and that will be produced. Solar energy is one of the classic example during last 10 decades where 100 gigawatt of installed capacity has been installed in this country. So nuclear energy choice is ours, whether we want to build the nuclear power plants in the country or not, and for that we have to be together. And generally, perceptionally, it is well known that nuclear energy is one of the best in terms of the carbon dioxide emission, mortality rate, footprint, energy efficiency, the construction material, sustainability is one of the best. And as has been said that COP28 said that we want to triple the nuclear energy by 2050. And this is very well said that we have got a very modest contribution of nuclear energy of 2%. Now, when we are saying that the government has made this 100 gigawatt by 2047 by nuclear energy, and that has given us a scientific thought, and we have written this article in the current science, key drivers for achieving India's 100 gigawatt nuclear power ambition. And that is our thought process. What we have done is that we have plotted as a function of year and the nuclear power capacity. What you see here is that our growth rate today is roughly 0.1 to 0.2 gigawatt per year. This document, Synchronizing Energy Transition Possibility Net Zero for India, what it says that if India wants to become a developed nation by 2047, our HDI should be 0.8. For that, we should have the energy, which I already mentioned, and if you have got 0.8 and net zero integrator scenario where you make an energy mix, our target should be 100 gigawatt by 2050. And if you give more thrust to the nuclear energy, then we should produce 365 gigawatt by 2050. And that is a very, very tall claim. Now, what you see here, if you want to achieve the 100 gigawatt by 2050, our annual growth rate should be 4 gigawatt per year. So generating 4 gigawatt in a year is not an easy task. So it requires a large amount of thought process. Now, what is good for the 4 gigawatt per year? The government support is there nowadays. Government is after us. They want us to do the power. We have got a mature technology, particularly PSWR, 700 megawatt. We have got 7 decades of O&M experience, and government is enforcing for the private partnership. Nuclear energy, what has gone wrong in my opinion is 2 things. One is the too much of stringent rules, particularly for radiation protection. And all the radiation protection laws have come from the linear no threshold model, which says that any X-ray or any ionizing radiation is potential for the genetic disorder. And that is the completely wrong rule which still persists in the nuclear industry. So, I might have delivered more than 150 lectures in various industries, civil societies, academia and industries. Everybody has got a fear of radiation. And the radiation fear is come because of this L&T model. Now, so what I feel is that instead of the L&T model, we should go for a threshold-based model. Now we choose a threshold model. That below this there is no risk of either cancer or the genetic disorder. Genetic disorder anyway has gone away at those low doses. If you do that, there is going to be a public perception. Everyone wants nuclear energy, but not in their backyard. Then there is a radiation protection laws. If you relax them, you can have a cleanest environmental relaxations. You can have a flexible workforce management. You can have the improved community acceptance. This second point, which I always feel is the problem with the improved quality infrastructure. Because of this L&T model, even the university systems, including the IITs, they have stopped their nuclear sciences courses. IIT Kharagpur, IIT Kanpur, and large number of private universities, they have stopped. Because in order to get even a microcurie source, they need to appoint a RSO. And then they say that this is not possible for them. So because of too much of fear, the nuclear science and engineering courses in the university system have been shut down, which is not a good scenario for nuclear energy to prosper in this country. So we have to ensure that this L&T model somehow goes away. The second is the improved quality infrastructure. As a chairman of NABL, I have interacted a large number of MSMEs. And they say that if I want to make a component for nuclear industry, where are the standards available? And I myself is the chairman of the CSD 30, which is for the peaceful application of nuclear energy. And hardly we have built any kind of Indian standards in this domain. So, ARB does make a standard, but they are related to the safety and security of the nuclear power and radiation related issues. But for the components of the reactors and other devices, we have almost none standards available. So we have to work upon that. And for that, we have to require the accreditation, standardization, and metrology. They are very key parameters. And then government industry academia relationship. And that will not only a guarded training program or training school, we have to expand it to the various universities also if you want to go to 100 gigawatt. So human resource development, not through the DAE only, but also through the industry and through the academia, we have to enhance that. And then if we have got done the time required, can be very faster. The biggest problem which has come into the L&T model is the wrong science done by the Hermann Muller. You see, today if you talk about, you do experiment on a Drosophila, which is a fruit fly, and say that any experiment done on a Drosophila are applicable to human being, nobody is going to believe it. But can we believe that our regulations are based on this Drosophila? He was doing experiment at below 300 millisievert, and he found none effect on the Drosophila. He got frustrated and he used 80 millions of the dose on the Drosophila, and he could demonstrate the genetic disorders. Now remember, in 1927, nobody knew where are the genes. Even the structure of DNA was not known. So it was the second generation, the traits which was affecting the second generation, they were revealed. This was indirect revelation. And somehow he gets a Nobel Prize in 1946. And 1943, Ernest Kasperi said that absolutely there is no effect below few hundred millisievert on the Drosophila. But while receiving Nobel Prize, he said that there is no threshold. And that has created a problem. That as a single hit can cause a genetic disorder became a problem. And that's why we have got so much of a regulatory one. And after getting Nobel Prize, he said that any radiation is harmful, which was a very, very wrong statement by him. So even ICRP is strongly influenced by the Hermann Muller's studies. And as we know that ICRP has given a certain regulations. US follows certain regulations, 50 millisievert per year, but unfortunately in India, we have gone even a further tighter one. It has got a wrong, good ramifications on the operation of decommissioning particularly. Chernobyl people talk about, and which I always make a statement, in nuclear industry, radiation does not kill, but regulation do kill. And one of the classic examples is the Chernobyl. In Chernobyl, based on the L&T model, they predicted almost 60,093 cancer cases, which will die because of this. Nothing like that has happened. There were total 6,000 cases which were identified, and 15 deaths were reported. So 15 deaths out of these 600,000 people is almost negligible. It is as good as the background. Worst part was that 100,000 women pregnant women, they were asked to go for the abortion. And that was one of the biggest problems that has happened. You see, history has now shown that large amount of experiments are being done in and around the Chernobyl. And even at the site where the accident took place, the only thing is that the frogs, they have evolved as a stronger but darker one. And darker one applies because the nature has given the melanin which can support from the ionizing radiation. And the life in and around the Chernobyl is flourishing. If you have got any life which is the best biodiversity is in and around the Chernobyl. It means radiation does not stop the life. Same as the Fukushima, everybody knows that because of tsunami, 15,000 people died. Not a single person died because of radiation-related cancer or anything else. But because of the ill-framed regulation, people were evacuated, more than 90,000 were evacuated, and they spent $55 billion and killed 1,600 people because of evacuation. It is just contrast to the Bhopal gas. We always talk about the Fukushima, Chernobyl, but we forget the Bhopal. Bhopal was a real disaster. Very next day morning when this methyl isocyanate was leaked, there was dead bodies like that. Nothing like that has happened neither in Chernobyl nor in Fukushima or anywhere else. So, US NRC has made a clear cut. The basic fact that radiation creates a genetic disorder at low doses has been failed. And this has been reported by the US NRC fact sheet now. No genetic disorder has, in fact, ANSCARE and ICRP, they have come up clear cases. Now, what we are hanging upon is that we have got excess cancer cases. Now, the excess cancer cases at low doses, contribution is almost minimal or almost negligible. In fact, it can be beneficial. So, the L&T model is anyway out in my perception. And what has happened was, because of this fear, even mining, when we take the rocks and we mine our uranium, people are scared of and people give this kind of wrong narration. Jadugada, the nuclear graveyard. And we have got this uranium tailing which has got now 2,000 crore tons of tailing lying there. And we feel that it's very highly radioactive. This is completely untrue. So what we have done in the last few years, we have used this tailing material, made a building out of it. And instead of storing now, people can use this. So we are looking for approvals and we can do it. As a health safety environment group, we have got ESLs in and around the nuclear power plants. And we measure the public dose from all the pathways. And what we could see is that the maximum dose is 40 microsievert per year against the 1,000 microsievert, that is 1 millisievert. And our nuclear reactors are very safe. And of course, the credit goes to ARB as well. Of course, this has been picked up by the leading newspaper, Times of India, that Indian nuclear reactors are safe. And as I respond to many of the parliamentary questions in the parliament and showing this data, many of them were really convinced that we are doing well. Even the Hindu, he made a lead story, no reason to worry because our nuclear power plants are very, very safe. We have also done the mapping of India's natural background, and we could see that in the beaches, because of the presence of thorium, we have got the natural background radiation up to 250 millisievert per year. And the Jacob Kosi, who is the science editor of Hindu, he asked that when the 250 millisievert per year dose is already available in the background, what is the sense of making that 1 millisievert per year extra in your regulation? Is it not a wrong one? And I said, yes, it is wrong one, but that need to be changed some point of time. Of course, this is the where people play, and there are study in BARC, Bioscience Group studies, where they find a negative correlation with the high doses, particularly for the cancer. So what should the modality? And the Calabresi, he has been talking about it, because always there is called a dose-response behavior. Ultimately, we are talking about a biological system, and anything which affects our body, any dose which comes, either food or toxic elements or radiation, how does it affect? So it has been shown that either vaccine, exercise, copper, selenium, low aspirin, you have got this J curve. At low doses, it is good, including your vaccines. So why it is not applicable to the radiation? When nature has already given you the background, and therefore there is a complete fallacy with the linear no threshold model. So basically what happens that the L&T model does not appreciate the repair mechanism of the biological systems. So LNT model, ionizing radiation comes, it falls on that there is a probability of DNA break, and therefore the probability of cancer is proportional to ionizing radiation. So that is the LNT model. What it didn't recognize was nature, biological system also has the immune cells. And when it falls, radiation falls on immune cells, they get activated, like our vaccines. And therefore, whatever the cancer cells are there, even in fact at low doses, that can be eliminated. And that is what is happening at the high background doses, where the cancer probability is much less. So if you put together, so there should be a beneficial effect at the 100 millisievert and below. And of course, the cancer, people talk about the cancer, diet is the number one cause of cancer, followed by tobacco, sunlight, and radiation hardly finds any way there. And we have done a probability of analysis. What we find is that the probability of excess cancer because of radiation is only 1 million times lower than our normal diet, because the reactive oxygen species are not produced by 100 millisievert dose. Of course, there have been a large amount of experiments done worldwide, still people are doing on that, at low doses is beneficial. For example, the medical applications, the radon therapy, Japan, Germany, everywhere they have done, except India. In fact, it is contradictory. If we don't have much of radiation, probably we will not survive. And one of the experiments done at very low doses, below background experiments, we show that the biological system do not survive if there is no radiation. And of course, the high radiation, everybody knows that 481 astronaut and cosmonaut, they have gone in the space, they experience high LET ones, and this science paper said that this is a contra-positive results. It means the probability of cancer, those who are exposed up to 400, 500 millisievert, the probability of cancer is much lower. And one of the classic examples, the Buzz Aldrin, who was the second person to land on the moon. So we have done a detailed analysis and published these papers where the low dose makes it effective for the goodness. And it is because we have got an activation of antioxidant system, adaptive immune system, apoptosis, and repair mechanisms. So up to few hundred millisievert, you can have all those ones, and hours, days, weeks, and months, it will give you beneficial effects. So based on that, we are invited a large amount of studies. The current science is invited for a guest editorial to us, a write on this one, and we write the revisiting radiation realities. What we said is that one of the worst things to happen in this scientific fraternity was the wrong studies of Hermann Muller. His Nobel Prize and making everybody fear of radiation. That was the wrong thing. The bad thing has happened that the consequences in the nuclear energy. We have over-regulated the nuclear industry. And the positive thing which is happening is that people have started realizing that radiation has got a good effect at low doses. And it should be propagated, and more fundamental science should be done on that. In fact, scientifically, it was the Schrödinger, the famous quantum mechanist. He said that life feeds on the negative entropy. And he was the person who gave the idea of what should be a DNA-like structure. And just to tell you that, we have got 23 pairs of chromosomes, and in the femtosecond volume, the total DNA length goes up to 2 meters. In 2 meter length one, only 0.1% of the DNA is coded with the genes, remaining a junk. So there is a need to do this kind of experiments, and I hope BRC will take up these kind of studies. The second thing which I found is very abnormal is that the Minister of Environment puts nuclear in the red zone, red category. If you take the US and France, they have got a unified regulation mechanism. The final regulation is given by the US EPA or ASN. In our case, we have got two mechanisms, and MOFCC has given a very, very weak signal, traffic signal, red, green, and white. And the red zone of nuclear energy is creating a troublesome for the nuclear industry. The second part which I wanted to put up is that the scaling of nuclear power plant will require scaling up of the number of MSMEs in the country. And for that, we have to prepare the strong accreditation system, certification system of the components, metrology, standardization, data management system, and that is where the DA should put huge amount of efforts. So we have to create a specialized MSMEs hub for manufacturing of nuclear components. As I said, that the BIS committee on the CSD30, that need to be populated. Large number of standards has to be formulated, and that should have an interaction with the MSMEs. The technology transfer and R&D collaboration should be done with the MSME hubs. Capacity building, skill development training, innovation grants. So BRNS and probably ARB, they should find some mechanism by which the research grant can be given to MSMEs and academia. Of course, GEM is the one of point of thing. The nuclear supply chain consortium should be formed. Agencies for type approval for those ones is still missing. Calibration testing labs. One of the classic example is that the NDRF, who uses our radiation preparedness, their equipments cannot be calibrated in the country. They are always telling that how to get calibrated, because the number of calibration labs in the countries are very, very minimal. They are not able to cope up with this kind of things. So, based on our experience, we have written 2 handbooks. That is the handbook on radiation environment. There's a volume 1, which talks about all the sources, applications, and policies. We have advocated that it is time to change the radiation protection policies in the world. Okay, ionizing radiation is a wonderful, because it gels with almost all the sustainable development goals of the United Nations, and that can give us a lead. So, in conclusion, in my personal opinion, I feel that nuclear energy is definitely a solution for climate change, but we should allow that to groom up. We should allow that to grow up. We can't hold up the nuclear energy. The applications of nuclear energies are enormous, apart from the isotope production, nuclear agriculture. The production of isotopes are very, very essential. And therefore, which I said that the stringent laws which are based on a wrong scientific principles need to be abolished. We should bring in a model, and in the country we should bring up a creditable mechanism by which large amount of MSMEs can become a part of the nuclear energy production mechanisms. And academia, we have to ensure, it is very sad story that most of the universities, they are closing down their nuclear energy and sciences. So we have to give that barrier and make them free from the requirement of our RSOs and this, and when they are dealing with the experiments. So we have to find a intermediate mechanism, and that can happen only when we bring on the threshold model at some point of time. So with these remarks, thank you very much.